So I'm back, and now, starting off where I left off, I was talking about the antimuscarinic drugs that can help with chronic obstructive pulmonary disease by blocking the muscarinic receptor pathways. I'm guessing that would be like from muscarinic 1 and 3 receptors, just because muscarinic 5 receptors are in your central nervous system. So we'd be looking at GQ signaling, we'd be inhibiting the pathway that activates phospholipase C and creates IP3 and diacylglycerol. Diacylglycerol stays in the membrane. IP3 goes down to the sarcoplasmic reticulum, causes the release of calcium. Calcium helps translocate protein kinase C to the membrane, and then the protein kinase C gets activated by diacylglycerol, and protein kinase C triggers some other things. Also, myosin light chain kinase ends up getting activated by probably the calcium modulin modulated protein kinase 2, CAMK2. Modulin gets activated because positively charged calcium 2 plus changes its structure, and that causes other things to happen. The end result is smooth muscle contraction. So ipratropium and tiotropium, those drugs cause bronchodilation. There's also mentioned in the book, Principles of Pharmacology, they mention methacholine, which causes bronchoconstriction, and this is exaggerated in asthma. That's a way to diagnose asthma. So here's another example of the drug, methacholine. Okay, moving on, let's move to the heart. The heart can be affected by drugs. Actually, there we go. If you take atropine, if atropine is injected or taken, that can cause tachycardia. It resists bradycardia and the vagovagal response, which would want to cause bradycardia and to decrease cardiac output, which isn't always a desirable thing. Sometimes you want to prevent that from happening. Atropine would prevent that from happening because it's anti-muscarinic. It can inhibit I'm thinking it's the muscarinic 2 receptors, I think, which are actually GI signaling that are antagonistic towards chronotropy, at least in your heart. So those are anti-muscarinic. I don't know of any pro-muscarinic. I think pyridostigmine or physostigmine might enhance your autonomic tone. So that would do the opposite of drugs like trimethophan, mecalamine, and hexamethonium. And so that may actually increase your vagal tone, but I'm not going to really mention that because I'm not sure. So moving on to adrenergic drugs. So you have drugs like isoproterenol and dobutamine, which are agonists of the beta-1 receptor. So S, and that causes increases chronotropy, plus chrono, and plus iono. Those are both through the beta-1 receptor. The beta-1 receptor also acts on the kidney and causes the renin-angiotensin, aldosterone axis to go, and that increases blood pressure. But in your heart, that increases chronotropy and ionotropy. Then you have beta blockers, which we have to put a red S here. And that decreases chronotropy minus. Okay, decreases chronotropy And I'm thinking that, yeah, that also decreases inotropy. So we'll also put minus iono. Decreases the force of contraction, probably decreases lusitropy as well, which means your heart doesn't relax as quickly either. So also beta blockers are going to affect your larger arteries. They're not going to be as vasodilated. They'll be more constricted a little bit. It doesn't necessarily help the beta 2 and beta 1 receptors, especially the beta 2 receptors in your muscles, do what they want to do, which is help your muscles get more blood and possibly help your muscles with storing more sugar and stuff. So, you know, if you don't need to take beta blockers, don't take them because they're not really that great. Let's see. That would also affect the liver, by the way. I guess I'm getting ahead of myself. So, moving to the blood vessels. I already talked a little bit about that. To start off here, the parasympathetic nervous system doesn't really affect the blood vessels throughout almost your whole body. So the parasympathetic nervous system isn't really relevant. But if you're going to increase signaling through, the sympathetic nervous system, you're going to, depending on what they bind to, if it binds to your alpha receptors, for example, you're going to cause vasoconstriction. So drugs like, I want to say, methoxamine and phentermine, those drugs bind to alpha-1 receptors, just like, also like tolazamide, I think, or tazolamide, Visine. Those cause constriction of the alpha-1 receptors and increase your blood pressure. So if you're in a state of shock, for example, which is caused by too much histamine and too much bradykinin being secreted into your blood because you're allergic to something and your immune system's responding, that causes all your blood vessels to get dilated, right? Which is not a good thing for moving blood through at an adequate pace and adequate blood pressure. In those cases, you're going to need something that is an agonist of those alpha-1 receptors to save your life. Otherwise, you die from shock, right? So that's one thing that a sympathomimetic would do, but also sympathomimetics that would affect beta signaling, for example, like especially beta 2 signaling, like some of the ones that I mentioned up here, I think. I'm trying to think which ones are specific for the beta 2 receptor, like levobuterol and some of those. If you were to put them systemically through your body, I would think they would cause vasodilation, and specifically your muscles and certain areas that need the blood when your sympathetic nervous system is activated. So, but just do that and not necessarily constrict your arterioles like in your periphery. But I don't know if that's ever really prescribed or used medically, but theoretically that's what it would do. So I'll say sympathetic activation increases blood pressure. Okay, and beta blockers, and even alpha-1 blockers like terazosin. I didn't talk much about beta blockers, like specifically, but some that are specifically block the beta 1 receptor would be like betaxolol, atenolol, metoprolol, esmolol, and labetalol, I think. It's nebivolol is the other one in the book. So those would actually specifically target your beta 1 receptors, would affect your renin angiotensin axis, and also affect chronotropy and inotropy, which are desirable when you have cardiovascular issues, where you need to decrease the amount of chronotropy and inotropy in your heart. Let's see. So that would be decreasing your sympathetic nervous system. And I'll just say, overall, it's a decrease in blood pressure, I guess. At least cardiac rate. You know what? We'll not do this. Let's just talk about the terazosin, the alpha-1 antagonist. So the alpha-1 antagonist causes venodilation and vasodilation in your arterioles, which decreases your blood pressure. So yeah, it still does decrease your blood pressure. Okay. So moving on to your liver, you know, there aren't any intended effects that I can think of from drugs that are cholinergic or adrenergic that are intentionally to affect your liver, although theoretically the beta blockers would decrease the response that would cause the breakdown of glycogen and gluconeogenesis that would occur in response to the sympathetic nervous system. I would think it would decrease that effect. And your stomach, drugs that are anti-parasympathetic, let's see, decrease activity. Like glycopyrrolate, for example, would decrease your activity. Moving down to the pancreas, M3 antagonists, especially the muscarinic 3 receptor antagonists, would decrease your pancreatic output, decrease insulin, but I don't know if that's an intended consequence. If you take any second generation antipsychotics like clozapine or olanzapine, for example, those drugs can inhibit your muscarinic receptor. If you drink alcohol, if you're drunk or something, that can decrease your insulin also. Those are bad things. So don't take antipsychotics and don't drink if you don't need to, because it's not really good. Eventually you could get type 2 diabetes, even though you're actually decreasing insulin output here. It would have other effects on other muscarinic receptors, other cholinergic signaling in your body. So, moving on, I can't think of any specific ones that are actually for your pancreas that are prescribed for that, just besides how bad second generation antipsychotics are and alcohol is. So, kidney. I did talk a little bit about that, but your beta blockers affect this organ. So that would be anti-sympathetic. Decrease renin. For adrenal medulla, drugs like alpha-methyltyrosine would stop the production of catecholamine, would help to stop some of the epinephrine and norepinephrine being released from your adrenal medulla if you have pheochromocytoma. So I guess that does help. That's adrenaline, I guess. Okay. Let's see if I can think of any other drugs for that. There's drugs actually that I didn't mention here that do block your sympathetic nervous system by blocking your alpha-1 receptors, like phenoxybenzamine, which actually blocks alpha-2 and alpha-1, and it alkylates those receptors, which is a permanent modification that changes the receptor and keeps it from being activated. And if you know anything about alkylation in biology and the cell and DNA, that's not really a desirable thing if you don't want to get tumors, because it's probably going to change your DNA as well. There's also phentolamine is another one that's a non-specific alpha receptor blocker that can also be used in cases of pheochromocytoma. Okay? So I'll just leave it at that. Let's see. And I can't really think of anything else for the kidney or for the medulla or adrenal medulla. Moving down, you have your digestive tract here. There are like anti-muscarinic drugs can help to slow down your digestive tract if it's overactive. So that would be, let's see, I guess I'll draw it here. Red P, decrease. Drugs might include methscopolamine and scopolamine. Scopolamine isn't as good though because it crosses the blood-brain barrier and can mess with your cholinergic signaling in your brain. If you're an older person, that's not a good thing because that can cause dementia and Alzheimer's disease-like effects by inhibiting cholinergic signaling. So that's why if you're an older person, you don't want to take drugs that mess with your cholinergic signaling, especially if they cross the blood-brain barrier. But I said, so glycopyrrolate, methscopolamine, scopolamine, and pirenzepine, I'm going to say propantholine. Those are all anti-muscarinic drugs that can help to decrease your GI activity. Also, you have, if it's a beta-3 agonist, it can also decrease activity. So I guess we'll go with S plus decrease. Whether I can't think of any examples, but I remember reading it. Decrease. If you increase your parasympathetic nervous system, that can be a good thing for like your bladder and your GI tract. That increases if you have an underactive digestive tract. I think if you have morphine, I think that's actually inhibitory towards neurons, even though you kind of think of the parasympathetic nervous system as kind of an inhibitory kind of pathway sometimes, not in the GI tract. So morphine is still going to inhibit at the terminals of the neurons. And you have a vast network of, you have a large, very large ganglion here throughout your whole digestive tract. You have the submucous plexus, which I believe is actually more internal. And then around radial to that, throughout the whole alimentary canal, you have the myenteric plexus. So myenteric plexus, I think. So this is almost like part of a brain. Like, I don't know if it's like a tenth of your brain and neurons, but you have a lot of neurons in your digestive tract. And so when you inhibit these or activate them, that has a lot of effects. So if you increase the cholinergic signaling, though, that does affect your digestive tract, it increases GI motility. So if you take drugs like neostigmine, and some of the drugs I mentioned up here, like neostigmine, physostigmine, and bethanechol, which can agonize the muscarinic receptor. I can't remember if it agonizes the nicotininergic receptor, but that may not really matter because this is in your GI tract. So it's a procholinergic drug. These procholinergic drugs increase the motility. I'm trying to think if there's any just pro-muscarinic ones I can think of, and I can't think of any right now. I already talked about the anti-muscarinic ones. So what am I missing here? Beta blockers, I don't know, I guess beta blockers might decrease the agonist activity in your beta-3 receptors, which might increase GI motility, but I actually don't really know that. Moving on to your bladder, some of the same things apply here. In fact, some of the same drugs. Some of the drugs are the same. So in your bladder, anti-parasympathetic drugs cause a decrease in the tone of your detrusor muscles, decrease your bladder activity. drugs like tolterodine, fesoterodine, let's see, solifenacin, darufenacin, terazosin. Actually, let's see. I actually brought this because I'm terrible at remembering these. Propanthyline, oxybutinin, trospium, terazosin, darufenacin, solifenacin. Yeah, so those are some of the drugs that can block the tone of your bladder. But then there's also drugs that I did mention earlier, like tasmulosin, doxazosin, terazosin, and even I talked about terazosin in the context of the vascular system. That one actually may have a little bit of an effect, but there's different isotypes of the actual receptors, so it doesn't have as much of an effect in the bladder, but I think it still does. It just has more of an effect in your vascular system, so why take that when you don't need to? So, in this case, these would be